Good morning, students. The chapter is the refraction of light at the plane surface. The topic is the refraction of light at plane surface. What is the refraction of light? The refraction of light, the phenomena, the refraction of light, the phenomena of change of path of light to going one medium to another. Repeated. Refraction of light, the phenomenon of change of path of going light, going rays, one medium to another. That is called refraction of light. To condition of refraction of light, let's draw a normal surface. Draw the normal surface. When light passes to rare to denser medium, then the reflected toward the normal. That is called normal. That is incidence. The refracted ray. If an incidence ray going to rare to denser medium, then the reflected ray toward the center, toward the normal. Another case, when incidence ray denser to rare medium, when incidence ray denser to rare medium, then the reflected away the reflected ray away the normal. The first case, if a incidence ray going to rare to denser medium, then reflected ray either toward the normal, and second case, incidence ray going to denser to rare medium, then reflected ray away the normal, away the normal. The two cases of refraction of light. The terms of, now going on the terms of refraction. The terms of refraction. Draw a normal. Let the first air medium to glass. A incidence going to rare, that is called rare, and that denser. So in first case, according to refraction of light, if a incidence ray passes to rare to denser, the reflected is toward the normal, and as it is the process the same, then surface if that is called incidence ray or reflected ray, that is called incidence point. Incidence point. Angle between incident and normal is represented by I, and normal to reflected ray they are represented by R. The going to the same direction, the represented by sigma, that is called angle of deviation. The angle of deviation. When a incidence ray passes ray to denser medium, then reflected ray toward the normal, that the incidence angle, the angle between the incident ray and with the normal, called the incidence angle, and angle between reflected ray and normal called reflected angle, that is presented by symbol R. Now solve the refractive index. Refractive index. In the last diagram, that is called I, that is called R, that is called incidence angle, that is called refracting angle. Law of motion, the first law of the motion, incidence ray and normal and reflected having same plane. And second, the angle of sin I, incidence angle, is equal to angle of reflected, sin I is equal to sin R, that is represented by sin I upon sin R is equal to constant. That is called the second law of motion, second law of light, and also that is called the Snell's law. That is called also Snell's law. Refractive index in incidence and represented by mu. The mu is equal to sin I upon sin R. The another case, if the refractive index of glass with the respect of air, the refractive index of glass with the respect of air, this means the velocity in air and velocity in glass. The refractive index represented by mu, the sin I. The I is equal to incidence angle, R is equal to refractive index. And another case, refractive index of glass with the respect of air, the velocity in air upon velocity in glass. Solve some numericals. In beam of light from air to medium X, if the angle of incidence, given the angle of incidence 45 degree and angle of reflected R is equal to 30 degree, calculate the refractive index of X. The refractive index of X is question. The formula of refractive index, sin I upon sin R. Then sin 30 upon sin 45. The value of sin 30 is equal to, what is the value of sin 30? Incidence 40 degree, 45 degree and reflected 30. The value of sin 45 1 by root 2 and sin 30 is equal to 1 by 2. Sin 30 is equal to 1 by 2, 45 is equal to 1 by root 2. The written 2 root 2 into root 2 upon root 2. The value of root 2 is equal to 1.414. That is the refractive index of X. Repeat that a beam of light passes from air to the medium X. The angle of incidence represented by I, then I is equal to 45, and refractive angle represented by symbol R, then angle R is equal to 30 degree. The formula of refractive index sin I upon sin I, sin 45, then sin 30. For sin 45, the value of sin 45 in trigonometry 1 by root 2, 1 by square root 2, sin 30 the value of 1 by 2. Put the value and answer. Another question. The refractive index of glass with respect to air. Refractive index of glass with the respect of air is 1.5. Find the value of refractive index of air with the respect of glass. Find the value of refractive index of air with respect glass. Then the formula of 1 upon AUG. 1 upon 1.5. Solve this. 5 3 ja 5 2 ja 2 upon 3 and 0.67 667 or 67. Another question. The speed of light in glass. Speed of light in glass. Velocity of glass 2 into 10 to power 5 kilometer per second. Change the SI unit meter per second. 2 into 10 to power 5 1 kilometer the 1000 meters and 10 to power 3 meter per second. The multiplication 10 to power 8 meter per second. What is the refractive index of glass? The refractive index of glass. The refractive index of glass, but with the respect of air, or light, speed of light. Then formula of velocity of light in air upon velocity of light in glass. The velocity of light in air, the constant value, the value is the 3 into 10 to power 8 meter per second. The velocity of light in air, a constant value, that is called speed of light. Also it is called the speed of light 3 into 10 to power 8 meter per second. The 3 into 10 to power 8 meter per second upon the velocity glass of light in given in question 2 into 10 to power 8 meter per second. 1.5 refractive index of glass with respect of air. Thank you.